So the question is 64 buckets of equal size full of water are taken out of a cube shaped tank full of water. Now, one third part of the tank remains full of water. If the length of one edge of the tank is 1.2 meter, calculate how many liters of water each bucket holds. So there is a water tank full of water. Okay, let us first understand the problem. So let me draw an outline. Suppose this is the tank. It is cuboid shape, cube shaped tank. Now let us this pool of water. So the problem says that 64 buckets are used to pull out some water. Then one third part of the tank remains full of water. So two parts, one, two, three parts. There are three parts to water. There are three parts of water. Then two parts are taken out. That is what the problem says. And one part is left. Okay. One three part of the tank remains full of water. So if we divide the total water to three parts, then one part remains, that is 1 out of 3. Then 2 out of 3 parts, that is taken out. This is extracted and this one remains. Okay, if we divide the total water into 3 parts inside the tank, it is full of water. Then it is given the length of one edge of the tank is 1.2 meter. So this is 1.2 meter. Okay, actually this looks like this. Okay, so this is the tank full of water. Then one is NES. This is 1.2 meter. So one three part remains after taking some water out by using some buckets. 64 buckets are used to take out some water. So if we divide the total water here to three parts, then one part remains and two parts is taken out by 64 buckets of water. That is the problem. Okay, that is what the problem says. Now the length of one of the edges is given, it is 1.2 meter. So we have to find out how many liters of water each bucket holds. The 64 buckets that were used to take out the water, how much water each of these 64 buckets can hold if they are used to take out total 2, 3 part of the water, leaving 1/3 part of the water, then how many liters each bucket holds? That is the problem. Okay. So here first we have to understand, first we have to find out how much water was held inside the tank. How many liters of water were held inside the tank? So how do we find it? How do we find out the total water held inside the cuboid? To find that, we have to find the volume of the cuboid. So that will give us the total water held inside the cuboid. So how do we find out the volume? It is easy. If you multiply it 3 times 1.2, 1.2, 1.2, 1.2, it is cubic meter. Okay. Why 1.2, 1.2, 1.2? Because it is length of one side. Okay, if you say the length is L, then the volume is L into L into L. Right? That is the formula for volume of a cuboid. Of a cube, sorry. It is a cube. It is not only a cuboid, it is a special case of cuboid, that is cube. So in a cube, all three sides are equal. So the formula for volume is L into L into L, or 1.2, 1.2 into 1.2 cubic meter. That is how volume is given. Now this is not very useful to find the volume of water. So what we do is, instead of 1.2 meter, we will convert meter to decimeter. Okay. Let us convert 1.2 meter to decimeter. Okay. Then this one becomes 12 into 12 into 12 cubic decimeter. Right? This one. 1.2 meter is 12 decimeter. So this is equal to this 12.12.12 length, breadth, height, 12, 12, 12 cubic decimeter. Now this one is equal to 1728, 12 into 12 into 12 cubic decimeter. Right? Volume of the cube is 1728 cubic decimeter. And again, we know that 1 cubic decimeter is 1 liter. Now it is easy to convert it to liters. If 1 cubic decimeter is 1 liter, then 1728 is equal to 1 cubic decimeter is 1.28 liters. So we find the volume of water that can be inside the tank. So this tank, it has 1728 liters in total. Okay, total 1728 liters. So if we can find how much of 2/3 is 1728, and how much is 1 and 3 parts of 1728, then we find our solution easily. So let us do that. Okay, so let me draw a line here. This was for explanation. Okay, So we have solution. Okay, we have some given information, that is shape of the tank, it is cube. Fine. Length of one is 1.2 meters. Total buckets removed is 64. 64 buckets were removed. 64 buckets of water. Then we have remaining water is 1/3 part. Okay, so here 1/3 part remains after taking out the water. So we have 1/3 part. So first we do the unit conversion. I already explained why we need to do the unit conversion like this, from meter to decimeter. Why you do that? To find the volume of water like this in liters. Length of one is 1.2 meter, which is 12 decimeter. Okay, then we need total capacity. Volume of the tank is 1 is cube, right? 1 is 1.2 meter. So volume is cube, and we already have 1 is 1.2 meter, 12 decimeter. Okay, total volume 12 cubic decimeter, right? Or if you multiply it, how much you get? 1728 liters. Cubic decimeter. We will later convert it to liters. Cubic decimeter, or 1.1728 liters. Then calculating water removed. total volume of water in the tank is 1 part. You see, we have divided into 3 parts. Okay, 1, 2, 3. It is total is 1 part. So we have to take this is as 1 part. So we take that total volume of water is 1 part. Remaining water is 1 by 3 out of this 1 part. Okay, 1 by 3 part is left. So water removed by how many buckets were used? 64 buckets. If you subtract this 1 by 3 part from 1 part, you get 2 by 3 part of volume. Okay, so out of 3 parts, 2 by 3 part is removed because 1 part remains. So 2 by 3 part of total volume was extracted. Volume of water or water volume. Okay. Hence, volume of water removed is 2 by 3 part of 1728 liters. Right? So we have to find 2 by 3 parts of 1728 liters. So that will give us the total volume of water removed. So which is equal to 1152 liters. So this much water was removed. Okay. Now we find the capacity of one bucket. So how do you find it? See, total 1152 liters were removed by how many buckets? 64 buckets, right? So how much water each bucket will hold? That is the problem. If 64 buckets in total remove 1152 liters, then capacity of each bucket is equal to 1152 divided by 64, which is equal to 18, and you give the unit also 18 liters. Okay, dividing this number by 64 gives us how much water each bucket will hold, right? So that is the answer. So the problem was that there is a tank full of water Then some water is removed by 64 buckets of 64 buckets. Then some water remains. You have to find the capacity of each bucket. So to do that, first we find the total volume of water inside the tank. So to do that, we have to find the volume of the cube. It is a cube. Okay, the tank is a cube. So to find the volume, we use this formula, L into L into L, or H into H into S. Okay. So what is that? It is, each edge is 1.2 meter, or we convert it to decimeter, 12 decimeter, because 1 cubic decimeter is 1 liter. So it becomes easier to calculate. So we find the volume of total water inside the cube by finding the volume of the cube by L into L into L, like this. So we find that total we can hold 1728 liter of water. So if total water that can be held is 1728 liters, and then 2/3 part of the water is removed by using 64 buckets, because one third part remains. So that means 2/3 part is removed. Then we find the 2/3 part. What is the total of 2/3 part of 1728 liters? So we find that is 1152 liters. So 64 buckets were used to remove 1152 liters. So if we divide it equally among 64 buckets, we get that each bucket will carry 18 liters exact. Fine. So that is how we arrive at the solution. Okay. So this is a 4 to 5 marks question usually. So if you are asked to write the solution, you have to write the solution like this. Okay. The steps should be like this, and you can also draw a diagram like this, so for explanation on the right hand side. Okay, you can write a diagram also like this, and don't forget to label it. Okay, I have labeled it like this is 3 parts, 2 parts removed, 1 part left. Okay, if you're not comfortable with the diagram, you can skip it, not a problem. But if you write a diagram, you have to label it properly. Okay, but without the diagram also it can be done. So you just have to write it as I have given it here. Okay, the complete solution will be like this. This on the left hand side, this is the complete solution. It contains the whole explanation how we arrive at the solution like this.